Hello. It is a bit of an unexpected topic, but I just got this box along with the task of getting its contents to work, so I figured I might as well make a video about it. It's a Radmor 5102TE, a Polish FM/AM receiver manufactured in the 80s. At its time it was considered one of the best, if not the best, high-fidelity audio receivers built in Poland. It cost around 3 average monthly wages and was highly sought after luxury product. Today it's still loved by Polish retro nostalgia fans for its timeless design and a decent sound. Radmor deserves a few words of introduction. It is still around today. It survived the fall of communism, which many other companies sadly did not, for example Diora. But currently its main product line consists of military and professional radios of various kinds. Back in the day, Radmor was known for building professional maritime and military radio equipment, as well as various specialized devices. In the 70s, Polish government assigned Radmor the task of creating a modern hi-fi audio receiver for the consumer market. The 5100 line of receivers was produced from 1976 to 1985 and featured a lot of innovative technologies such as highly modular design, pre-armament, a feature which allowed to preset up to 8 radio stations, and a computer-controlled manufacturing quality. The unit which we have here is the latest model in line, 5102TE, which differs from earlier 5100 and 5102 mainly by replacement of analog meters with the LED indicators for signal strength and FM detector 0, and also abandonment of channel level meters. This model also has possibility to insert a graphic equalizer into an audio signal path. This unit is from 1983, as two first digits of its serial number are 8 and 3. It's a little bit dirty, but otherwise in rather good shape as for its age. It powers up, but has noisy volume and other potentiometers, and its FM tuner is tuned to an old FM band used in Poland before year 2000. Here you can see old and new band plans for Polish FM broadcasts. The plans have changed around year 2000 and essentially made all older FM receivers mute. They all required retuning their FM frontends to a new band. My task with this 5102TE here will be to clean it, check for possible aged capacitors and retune FM frontends to a new band. To retune FM frontend I will use this article which describes entire procedure in great detail. Let's start by opening the receiver. It seems that the rear screws are covered in wax. Can this be some kind of a factory seal? That would be great news, as it would mean that I am the first person opening the receiver since it had left the factory. The wooden case consists of 3 parts made of a chipboard covered with veneer, a thin sheet of wood glued onto the chipboard surface and painted. Here we can see the inside of the receiver. It is amazing how modular this design is. Inside the case there are 2 levels on which the boards are mounted and interconnected with a wiring harness. Additionally, the FM path boards have a separate backplane board. Let's take a quick look at visible components. Here we can see the transformer, one of the power supplies and the volume control board. Here on the lower level there is a sound control board, and on the back 2 modules in FM signal path, the stereo decoder and automatic tuning control board. Here in the front of the receiver there is a LED indicator board with signal power level and FM detector 0 indicators, and on the back there are remaining FM boards, middle frequency board and FM RF front end. Let's start with a basic cleaning to remove the thick layer of 30-year-old dust from the components. Next, we will begin removing the knobs to prepare for the removal of the front panel. Removal of the front panel requires some careful handling, but once it's removed we gain access to all the potentiometers, the LED indicator board and the pre-OMAT station programming unit. After removing the front panel, we will begin an initial rough cleaning. The panel is in good condition with no scratches, but it seems to be stained with some kind of lacquer or paint. Fortunately, this comes off easily with a swab dipped in isopropyl alcohol. Now the knobs. This is a satisfying part, cleaning off decades-old dirt to reveal their shiny surfaces. Some of the knobs have minor scratches and I might try polishing them later. All of the front panel parts are clean and shiny. Now let's move on to the next step, retuning the FM receiver. First let's take a closer look at the schematic of the RF frontend and see what needs to be done here. Here we can see PGU3 module, which is the receiver's FM RF frontend. There are basically three parts here. Input filter and amplifier, a local oscillator called in Polish heterodyne, mixer and output filter. Frequency of the local oscillator and frequency response of the filters is retuned by changing voltage level applied to varicap diodes present in RF frontend. Varicap diodes basically act as a voltage level controlled variable capacitors. This allows to retune the RF frontend to another frequency. Local oscillator produces signal of frequency which we want to tune our receiver to, increased by 10.7 MHz. This signal is then mixed with amplified and filtered input signal to produce middle frequency signal sent to a middle frequency module for FM demodulation. My task will begin with removal of 4 capacitors from the front end and replacement of a 5th one. Next I will replace U33 ferrite cores in 3 inductors to a U11 cores, which perform better at higher frequencies. Tuning will start with setting local oscillator frequency range with variable inductor and capacitor in local oscillator circuit. Then I will have to adjust 3 variable inductors and 3 capacitors in signal path for a maximum signal amplitude. To do that, I will use 3 tools: small handheld spectrum analyzer, oscilloscope and a Raspberry Pi as an FM signal generator. I remember reading somewhere that some very clever people wrote the software which allowed to transmit FM modulated RF signal out of a GPIO pin of Raspberry Pi. Now is the time to see if this amazing software really works. Let's clone the GitHub repository for FM transmitter software, compile it and try it out. The software will broadcast an FM modulated 22 kHz wave file on a specified radio frequency. It compiled OK and seems to be doing something. Let's see if we will be able to receive the broadcast on this handheld receiver. I will broadcast a wave file on 100.8 MHz and I will tune the receiver to the same frequency. It works. Before I will start taking the 5102TE apart, I want to check the state of varicap tuning voltages supplied from pre-OMAT programmer. To do that, I will set program 1 to the lowest frequency of the band and the program 2 to the highest frequency of the band. Then I will measure both voltages to see if they are in spec. Low tuning voltage should be around 3.0 volts and high tuning voltage should be around 25.0 volts. The voltages seem too low. I have also checked power supply voltages. They should be 40 volts and 18 volts, and they also seem about a 1 volt too low, around 39 volts and 17 volts. For such an old unit, I think it's fairly okay, but of course we will adjust all these voltages later. Last thing I want to check before dismantling electronics of the receiver is if I will be able to see signal generated by local oscillator on my handheld spectrum analyzer. I have connected a piece of coax cable stripped off the shielding as an antenna for analyzer. As we can see, it is clearly able to pick up a local oscillator signal. This will be handy while adjusting it later. I will now take all FM path modules out, check some of the electrolytic capacitors to see if they are in spec, and prepare FM frontend for retuning to a current FM band plan. Here we can see the modules which were hiding beneath the FM path: amplifiers for left and right channel, phono preamp and AM tuner. The smaller capacitors, 4.7 microfarads and 10 microfarads, have very high ESR and increased capacitance. Larger ones vary, some are okay, but some also seem a bit off the specified parameters. This means that electrolyte and probably also dielectric insulator have changed their properties over time. For now I will replace all of the capacitors in FM band modules, and we will see how the receiver will behave after putting it back together. Some of the capacitors clearly leaked some of the electrolyte. Fortunately, it did not affect the PCB itself. Okay, now let's prepare the front-end board for retuning. Here I have all the needed parts. I will remove 4 capacitors, replace 1, and replace 3 coil cores. The coils are sealed with wax, which I will have to remove first with some sharp tool. After recapping and modifying our front-end, I have installed FM boards back to the unit. Let's see if we will be able to receive any FM broadcast now. And yes, there's something, but it's noisy as the FM front-end is not adjusted yet. I will start FM tuning with checking and adjusting varicap tuning voltage first. As power supply voltages were about 1 volt too low, I have adjusted them to spec 40 volts and 18 volts. Let's see if varicap voltages are now okay. And they're not. Low end voltage is still off by half volt, and upper end voltage, well, that's interesting. The multimeter is not even able to measure stable voltage. That's not great. Why this can happen? At this point, I was thinking that adjusting power supply voltage will also bring up varicap voltage, but I was wrong. Plus 32 volt varicap voltage is produced from plus 40 volt rail by additional UL1550 stabilizer, so these voltages are not directly dependent. I see another electrolytic capacitor here just after the stabilizer. I think that will be first thing to check and possibly replace. After facing the issue with unstable plus 32 volt varicap voltage, I decided to replace all of the capacitors in main power supply, preamp, audio control boards and output amplifier. Removing all these out-of-spec unstable components will be the best way to achieve some level of stability and will remove uncertainty from further troubleshooting. Main power supply caps seem to be good. ESR is low, capacitance is a bit too high, but acceptable. I think it's within acceptable tolerance. I'm thinking that if I have already removed these 40-year-old parts, I will not put them back. I have already ordered new capacitors and I will put new ones instead, but I will leave these old ones in case I can need them in the future. Now let's remove the boards and modules on which I will replace the capacitors. I will also clean volume, bass, treble and balance potentiometers and also preamp potentiometers. Okay, I hope that the voltages will be stable now. Let's put everything back together, adjust power supply voltages once again, and try to set varicap voltages for all of the programs. Here are the preamp modules. I did not realize that I can turn potentiometers regulating varicap voltages from the bottom of the case, even when the module is installed. This is for all of them, for 3 volts for lower boundary of the band, and these are for 25 volts for the upper boundary. I'm trying to get same low end voltage for all of the programs, but it does not seem to be possible. I guess this is related maybe to aging potentiometers in the preamp. It doesn't matter that much, they can be a bit lower, but should not be too high, as such program with too high voltage will not be able to tune the receiver to the lower end of the band. For the upper end of the band, there are separate potentiometers for each program, so I can easily set plus 25 volt for all of them, and the voltage seems stable after replacing all these electrolyte capacitors. Now let's set the local oscillator to cover the new FM band. This is how I have adjusted the local oscillator range. I have added 2 presets on the spectrum analyzer, one for low end of the band plus 10.7 MHz, one for the upper end of the band plus 10.7 MHz. Next, adjust the coil to the low end frequency boundary, that is 98.2 MHz. I have made a small half megahertz mistake here, as the center frequency is visibly set to 97.7 instead. which I had to correct later off camera. Next, load the preset for upper end of the band and adjust the local oscillator frequency to the center using a variable capacitor in local oscillator. The same mistake here, 119.2 instead 118.7. Here are the two components which are used to adjust local oscillator band: coil for low-end frequency and variable capacitor for the upper-end frequency. Now the filters in signal path. The procedure will be: first, let's broadcast FM signal on the lower boundary of the band, adjust 3 coils for the maximum 10.7 MHz signal amplitude, measured with a scope on the output of the RF frontend. Then do the same for upper boundary of the band. Broadcast the signal, adjust 3 variable capacitors for maximum signal amplitude. Finally, broadcast the signal in the middle of the band and adjust coil on the output of our front-end filter and coil on the input of the middle frequency module for maximum signal amplitude. I'm using metal screwdriver here, which is incorrect, of course, because it changes inductivity of the coils, but the coil cores are turning very hard and I have already broken 2 plastic tools. So I have to wait for a second for the signal to stabilize to get a good reading. Next I will try to adjust power level meter, as now it is constantly showing good signal quality even if the receiver is not tuned to any station. I will detune the receiver from the station and set the indicator to 0. Then we will see how it behaves for already programmed stations. I will not touch anything further down the signal path, as stereo coder for example or amplifiers. The receiver works well, covers entire FM band as intended, signals are quite strong and I have only 1 meter cable as an antenna. This amplitude modulation on some of the stations is unexpected. I don't know the reason for this. Maybe someone is able to explain why I'm seeing this on the scope.
Podpisano jeszcze zapis o dodatkowej niedzieli handlowej w grudniu i ten przepis prezydentowi się nie podoba. Reporter tego ten Maciej. Łatwiejsze?
Według mnie może być łatwiejsze dla większości osób, bo to wiadomo też kwestia.
After adjusting signal indicator, my work here is finished. I will seal the coil cores with wax and check power rails once again. The voltages seem to slowly creep up, but I think this is normal as the receiver gets warmer. Okay, now let's put everything back together. And here is a rookie mistake in Radmor fun world. These keys can be mounted only before the front panel is mounted to the unit. Let's fix large capacitors in the power supply in place, as they only have their terminals and there are no additional mounting pins or anything like that. Here it is, cleaned, recapped and retuned. It sounds great, if I can say so myself.
W ciągu dnia także zachmurzenie duże i temperatury w nocy 0 stopni, 5 dzień przyniesie. Radioram. Teraz tak zagramy. A co?
Let's check if the automatic frequency control works as expected. I will detune the receiver slightly and press AFC button. The receiver is tuned automatically to the center frequency of the broadcast. Let's put the wooden case back on. It requires a bit of work and polishing, as there are marks on lacquer, probably from hot mug or something similar, but I will not take care of that now, and I will leave it to the owner of the unit. Okay, my work is finished. This is the first FM receiver which I have retuned, and as for the first one, I'm quite happy with the effect. It covers entire current FM band, the signal is clean and strong, even here in the basement on a 1 meter cable, and all controls work as expected. And that's it for this video. Next time I will probably go back to the more familiar world of digital electronics. Thanks for watching and bye!